In this intermediate algebra review tape, we're going to go over our work involving equations and inequalities. We're going to solve first-degree equations and inequalities with and without absolute values. For our first example, we'd like to solve the following equation for x. 8 minus 5 times x plus 2 equals 3x plus 4. Take away, in parentheses, x minus 8. Okay. Now, first thing to do is to simplify both sides of the equation and then to try to solve for x. You know, we're allowed to add and subtract the same quantity both sides of an equation, multiply or divide both sides of an equation by the same non-zero quantity, and we'll get an equivalent equation. The idea is to isolate x. Okay, now you have to be careful. Resist the temptation to go 8 minus 5 is 3. Order of operation still prevails here, and we first perform this multiplication, and then, only then, you subtract it from the 8. So, let's see what we have. Let's distribute the minus 5 through the parentheses. We have minus 5x minus 10 equals 3x plus 4. Subtracting this is the same as distributing a minus 1. Minus 1x. Minus 1 times minus 8 is plus 8. Now let us simplify each side independently first, looking for like terms to collect. We have minus 5x. 8 minus 10 gives us minus 2. 3x and the minus 1x for 2x, plus 4 and plus 8 for plus 12. All right. Now we'd like to get the terms involving x on one side of the equation and the constant terms on the other. Doesn't matter which way you do it. If, for example, we add 5x to both sides of the equation, we will get all the x terms on the right side. We'll have here the 5x's cancel out, minus 2 equals 7x plus 12. If you then subtract 12 from both sides of the equation, we will get minus 14 equals 7x, and dividing through by 7, we get that x equals minus 2, which is the answer. Of course, in an equation we should check. Substituting back in, the minus 2 plus 2 gives us 0. So the left-hand side we have 8 minus 5 times 0. The left-hand side is just 8. On the right-hand side, we get minus 6 and plus 4, that's minus 2. Now here, minus 2 minus 8, that's minus 10. Minus 2 minus a minus 10, minus 2 plus 10, also giving you 8. So it does check out. Okay. Now let's look at the following inequality. We want to solve the inequality for x. And we have 5 plus 3 times 2 minus x less than or equal to minus 4. Okay, now when you are working on an inequality, many of the rules are the same as when you work with equations. You are allowed to add or subtract the same quantity to both sides of the inequality. You get an equivalent inequality. You can also multiply or divide both sides of an inequality by the same non-zero quantity. If, however, you're multiplying or dividing both sides by a positive quantity, then you leave the inequality going the same way. If you are multiplying or dividing both sides of an inequality by a negative quantity, you reverse direction of the inequality. If it's less than or equal, you make it greater than or equal, so on. Aside from that, basically, you work as if you were working with equations here. Okay. Once again, you have to resist the temptation to say 5 plus 3 is 8. You have to remember that this multiplication must precede this addition. So 5 plus now 3 times 2, that's 6. 3 times minus x is minus 3x, less than or equal to minus 4. Combining the constant terms, 11 minus 3x, less than or equal to minus 4. And let's try to get x alone on one side of the inequality, so we can subtract 11 from both sides. This will give us minus 3x, the 11s will cancel out, less than or equal to minus 15. We're going to divide both sides by minus 3, but since it is dividing by a negative number, we're going to reverse the direction of the inequality. We have minus 3x minus 15. We would like to divide both sides by minus 3. When you divide by a negative, you must reverse the direction of the inequality, giving us, here the minus 3's cancel, we have x greater than or equal to minus 15 over minus 3 is plus 5. All x values greater than or equal to 5. We might also have an inequality in the following fashion. We want here to solve for x. We have minus 9 less than or equal to 2x minus 5 less than 1. Okay. When we have a continued inequality of this form, what we try to do is get x alone isolated in the middle, with numbers on either side here. Okay, well, here we're working for x alone in the middle. Okay, so to do that, we will first add 5 to all parts of the inequality. You just do it the same way. Whatever you do to one part, you must do to the other two parts here. Minus 9 and plus 5 is minus 4, less than or equal. Here the 5's go, we get 2x less than or equal to 6. Okay, we are now less than 6. It was a less than or equal here, but just a straight less than over there. Now to get x alone, we're going to have to divide through by 2. We're going to divide through by 2. But since we're dividing by a positive number, we will keep exactly the same directions that we had originally in the inequality, giving us minus 2 less than or equal to x less than 3. As our answer. Understand that this means minus 2 is less than or equal to x less than 3, or minus 2 is less than or equal to x, x is greater than or equal to minus 2, and at the same time it is less than 3, that it is between minus 2 and 3. It could be equal to minus 2, but it's strictly less than 3. By the way, if we were to exhibit these two answers, say on a number line, this one over here, this is 0, here is minus 2, 3. Here we would have, starting at minus 2 up to, not including 3. In other words, everything from minus 2 to 3. Minus 2 is included, 3 is not. Over here, x greater than or equal to 5. And this is 0, and this is 1, 2, 3, 4, 5. Starting at 5, going off to the right. 5 and up, and here's everything between minus 2 and 3, including minus 2, but excluding the 3. Let's consider the following. Let's call this 4a. Solve for x. The absolute value of 5x plus 3 equals 8. A first degree equation, but it involves absolute value. The question is what to do here. Okay, let's look at a simpler one first. Let's suppose I had the absolute value of x equals 5. A simpler equation involving absolute value. The absolute value of a number refers to its distance from the origin on the number line. We're saying here that the distance between x and 0 on the number line is equal to 5. So what does it tell you about x? Either the number x was 5 units to the right of 0, or it was 5 units to the left of 0. In other words, x could have either been 5 or minus 5. Its distance from the origin was 5, or from 0 was 5, so it is either 5 to the right or 5 to the left. Or think of it this way. A number without its sign is 5. What was the number originally? Either x was 5 or x was minus 5. Okay? And one can do this in general. If you had, for example, the absolute value of something z, for example, is equal to a. We'll assume a here is a positive number. If the absolute value of z equals a, either z equals a or z equals minus a. This is your basic rule for working out an absolute value equation. The absolute value of 5x plus 3 equals 8, either 5x plus 3 equals 8 or 5x plus 3 equals minus 8. If this works for you, fine, use it. In other words, z is whatever is in the absolute value sign. In this case, it's 5x plus 3, a is 8. So first you write z equals a, and then you have z equals minus a. Or 5x plus 3, you figure it out, you drop its sign, it's 8. So either it was originally 8 or it was originally minus 8. So when you dropped its sign, you got 8. So you have two simple equations to solve. Here we get subtracting 3 from both sides. 5x equals 5. X equals 1 when you divide by 5. Here, subtracting 3 from both sides. 5x equals minus 11. X equals minus 11 fifths. So we have two possible answers, and we can easily check these in the original equation. If x equals 1, 5 plus 3, we get the absolute value of 8, which is 8. If x is minus 11 fifths, minus 11 fifths times 5 is minus 11 plus 3 minus 8, the absolute value of which is also plus 8. Now suppose I give you another absolute value equation. Looks a little similar to this, slightly different. The following here. Solve for x. The absolute value of 5x now plus 3 equals 8. In other words, only the 5x is in the absolute value sign. Okay. You do not say 5x plus 3 is 8, 5x plus 3 is minus 8. I meant exactly what I had here. It has to be in the form the absolute value of something equals something. Then you can use this. The absolute value should get it isolated on one side. So I would start off by saying the absolute value of 5x equals 5. Now it's in the form the absolute value of z equals a. The absolute value of z equals a, so you say either z equals a or z equals minus a. 5x, when you drop its sign, is 5, so either 5x was 5 or it was minus 5. Leaving you x equals either 1 or x equals minus 1 as your two possible answers. And checking back in here, this gives you 5 plus 3 equals 8. For minus 1, minus 5, the absolute value is 5 plus 3 also equals 8. So it is important that it should be exactly in this form. The absolute value of something equals something. Then you can say z equals a or z equals minus a. As a variation on that, it is possible to get an equation both of whose sides involve absolute value. For example, suppose I say solve for x. The absolute value of 2x minus 3 equals the absolute value of x. And the idea here is the following. The absolute value of y equals the absolute value of z. When you drop their signs, the numbers are the same. This is basically what this is saying. So what does this mean? Either the numbers were really identical, or they were negatives of each other. Either y was equal to z right off the bat, or y was negative z, but when you drop the absolute value, it didn't really matter. And that's how we handle a problem like this. The absolute value of 2x minus 3 is equal to the absolute value of x. So these two numbers, when you drop the sign, they're the same. So either they were really the same, 2x minus 3 equals x, or 2x minus 3 was equal to negative x. All right, let's see what we get here. Minus 2x, you get minus 3 equals minus x. And you can multiply both sides by minus 1 to get x equals 3. And here you can do the same thing, subtract 2x from both sides. We get minus 3 equals minus 3x, dividing both sides by minus 3. we get x equals 1. X equals 3 or x equals 1. And let's check these. If x equals 3, 2 times 3, 6 minus 3, that's 3. The absolute value of 3 is equal to the absolute value of 3, no problem. If x equals 1, 2 minus 3, that's minus 1. The absolute value of minus 1 equals the absolute value of plus 1. And once again, that does check out. If you drop the signs, they both come out 1. Okay, I just want to point out one more thing in this example. And when I say the absolute value of 2x minus 3, some people get confused. I'm talking loosely. I'm saying, well, number without its sign. I'm talking about the entire quantity. You can't just go around dropping signs wherever you see them. You don't make this 2x plus 3 because it's an absolute value. Okay? It's either the numbers were exactly the same or they were the negatives of each other. But do not think that the absolute value of 2x minus 3 is just 2x plus 3. So when this whole thing is worked out first, then you take the absolute value of the result. Okay, now I'd like to work out some absolute value inequalities. Before we start do the next two examples, let's consider something like this. If I say the absolute value of x is less than 5, what does that mean? Okay, that you could say, looking at the number line, distance between x and 0 is less than 5. Here is 5. Here is minus 5. If the distance between x and 0 is less than 5, that means x must lie somewhere in this range. Between 5, you can go 5 to the right, 5 to the left. In other words, someplace in between, going 5 to the left and 5 to the right. Its distance the distance between x and 0 has to be less than 5. Because you're only allowed to go up to 5 on the right here or to the left 5 units. Somewhere in this range. In other words, x must be someplace between minus 5 and plus 5. This is equivalent to this. This is a symbol means is equivalent to. All right, another way of looking at it, you have a number x, you're going to drop its sign, it's going to be less than 5. So what do you know about that number x? Well, either it was a positive number and it was less than 5, like 1, 2, 3, 4, something like that, or 2.5, 3 1/4, whatever, anything in between. Or might have been a negative number like this, like so, between minus 5 and minus 1. Now you may say, well, minus 6, isn't that less than 5? But we're taking the absolute value. So when you take the absolute value on the minus 6, you get plus 6, and that isn't less than 5. So you're only allowed to go in this range from minus 5 to 5. Okay. We can sort of extend that in general. If we have, say, the absolute value of z is less than a, where a is some positive number, we can say that this inequality with absolute value is equivalent to the following continued inequality without absolute value. Minus a less than z less than a. This means z is greater than minus a and less than a. It is not enough, for example, to say that x is less than 5 here. Okay, because you can't go forever. If you hit minus 6, you're in trouble. Or anything less than minus 5, you're in trouble. X is less than 5, and at the same time, it's got to be greater than minus 5. Okay, this is the idea of and is implied in this continued inequality. Okay, bearing that in mind, let's work out the next example, which is to solve for x. The absolute value of x minus 2 is less than 3. Basically, the way we approach these absolute value equations and inequalities is to get them down to equivalent equations and inequalities that do not involve absolute value. Okay, by using this kind of a geometric argument or an algebraic argument, thinking about a number without its sign, somehow to interpret it without the absolute value. Okay, the absolute value of x minus 2 is less than 3. This is like the absolute value of z is less than a. Okay, mapping it up to this, that means minus 3 is less than x minus 2 is less than 3. If this number without its sign is less than 3, then the number originally had to be someplace between minus 3 and plus 3. And finally, we can solve by adding 2 to all parts, giving us minus 1 is less than x is less than 5. X had to be someplace between minus 1 and 5 if the absolute value of x minus 2 is to be less than 3. In other words, you can work backwards as well. This is equivalent to this. You can follow the steps this way, or you could work backwards. These are equivalent inequalities. Okay. In the last problem, I want to consider the absolute value of x minus 2 is greater than 3. Before we get to that, let's consider a slightly simpler one. What if I had the absolute value of x is greater than 5? A number without its sign is bigger than 5. Well, clearly x could be bigger than 5. It might be somewhere in this area. Or it's 6, 7, 8, 9, 10. The number is certainly, absolute value of that number is certainly greater than 5. But you have another range of possibilities. Minus 1, minus 2, minus 3, minus 4. Here's minus 5. You might also be on this side. Here are numbers which, when you drop the sign, they're also greater than 5. For example, minus 6, minus 7. Strictly speaking, minus 6 is, of course, less than 5. But when you drop its sign, it will be greater than 5. Okay, so we have sort of two possible ranges of answers. Either x could be greater than 5, or x could be less than minus 5. Another way, you could say the distance between x and 0 has to be more than 5. So either it's more than 5 units to the right, or it's less than 5, or it's more than 5 units to the left. In other words, in either extreme. But here we have basically the idea of or. There's a big difference between this and the inequality we worked out before. The inequality we're working out before, when you see it continued like this, this is and. Okay? The absolute value of z was less than a. Z had to be greater than minus a and less than a. Remember, we worked out the absolute value of x less than 5. That means you had to be someplace between minus 5 and 5. You not only had to be less than 5, but at the same time you had to be greater than minus 5. It was an and idea. Both conditions had to be satisfied simultaneously. Here, this obviously cannot be an and. You cannot be both greater than 5 and less than minus 5 at the same time. So we have two sets of possible answers. Either x is greater than 5, or it could be less than minus 5. And we can interpret this in our z notation. If you have the absolute value of z greater than a, this is equivalent to either z is greater than a or z is less than minus a. In other words, in either of the extremes. Knowing that, let us work out this example here. We have in the form the absolute value of z is greater than a. By the way, if this had been greater than or equal, then this would be a greater than equal, this would be a less than or equal. We would include the equality on all of them. The absolute value of z is greater than a. Either z is greater than a, or x minus 2 is greater than 3, or x minus 2 is less than minus 3. In other words, either x is greater than 5, if you add 2 to both parts, or adding 2 to both parts here, x is less than minus 1. Now, some people get sloppy here. They feel they should be able to do some kind of a deal like they did on the first problem. Okay? Over here, they said, well, the answer was minus 1 less than x less than 5. Isn't there some simple way to combine this? And they feel that they should be able to go something like this. Why can't I, they reason, say something like minus 1 is greater than x is greater than 5? And in fact, they can work backwards, and they say, why can't I do this whole thing with greater than? And they do the entire thing. Minus 3 is greater than x minus 2 is greater than plus 3. And they feel they could all do it continued. It doesn't work that way. What does this mean? Okay, well, they say, look, x is greater than 5. That's right. They say minus 1 is greater than x, so x is less than minus 1. That makes sense. The big difference, of course, is that this means or and this means and. This means that x is both greater than 5 and it is less than minus 1, which of course is impossible. Furthermore, this implies that minus 1 is bigger than x is bigger than 5. It implies that minus 1 is bigger than 5, which also makes no sense. Okay, so on the absolute value greater than inequality, you must break it up. On the absolute value less than inequality, that you can do in a continued fashion. And that brings us to the end of this table.